Hello everyone. Good evening. Welcome to Manorama Horizon revision classes. Today we will be dealing with metals and non-metals, chapter 3rd of class 10. Okay. Can you hear me? Okay. So it's starting, right? So we'll wait for 1 minute for everyone to join. If your friends are there, means tell them to join quickly. The same you can see in YouTube as well. Uh, friends are there, means you can let them also know. Okay, let's start. Otherwise, we cannot complete on time. Okay, so let's start. So in this chapter, we will understand the physical properties of metals and non-metals. We are going to study metals and non-metals, right? So we'll discuss the physical properties and we'll discuss the chemical properties of metals and non-metals, and we'll see how metals and non-metals react, that reactions, then corrosion, that topic we will see metallurgy topic, etc. Okay, so we'll have a quick look over all these topics, and if you face any difficulties or if you have any doubts, you can ask in between. You can post in chats. I will give the answers as well. Okay, so let's start. So first, we'll see the physical properties of metals and non-metals. Okay, so metals, we know that metals have shiny appearance. We call that property as lustrous. So in the same way, non-metals, they are not having that shiny surface, so they are non-lustrous. So all metals are solids, we know that. Exception is there for mercury. We have to note that exception. Okay, so exception is there for mercury. Mercury is actually a liquid metal. Okay, 1 minute. Okay. So mercury is a liquid metal, and this question has been asked in many of the board examinations. So note this down. Mercury is a liquid metal. All other metals are solid in nature. Okay. So non-metals, they are generally soft except for diamond. Diamond is hard. We know that. Okay. So diamond is a non-metal which is hard. Usually non-metals are soft. We can see in chemistry all over, if we are studying, if we are reading something, we can see always exceptions. Okay. So keep these exceptions in mind. We'll get always questions from these exceptions. Okay. So then metals, we can draw metals into thin wires, and this property is known as ductility. So metals are ductile. In the same way, non-metals are not non-ductile. Then metals can be converted into sheets. So this property is known as malleability. Considering non-metals are non-malleable in nature. Okay. So then metals are good conductors of electricity and heat. So lead and mercury are exceptions there. So not that exceptions, lead and mercury. Lead and mercury are exceptions. Okay. So then non-metals. Non-metals are poor conductors of electricity and heat. Exception is there. Graphite is a non-metal which is a conductor of electricity. Graphite conducts electricity. Okay. Then metals have high density, high melting point. Usually we know this property very well. From lower class itself, we have studied that metals have high density, high melting points and boiling points. Okay. So exception is there. For sodium and potassium, they are having low melting point. Okay. So then they have low density compared to metals who non-metals and low melting point except for diamond. Diamond is having high melting point. It's hard also. Then metals give basic oxides. Okay. So metals on reaction with atmospheric oxygen will get basic oxides. Non-metals gives acidic oxides. Okay. Then we'll tell metals are sonorous. That is, when strikes on hard surface, it produces sound. Same time, non-metals are non-sonorous in nature. Okay, we'll see now the chemical properties. Before that, if you have any doubts in physical properties, you can ask now. Do you have any doubts over there? Okay, reply quickly so that we can move fast. This physical properties, those are simple, very simple. We have studied it from lower classes, so there might not be any doubts in that, right? So we'll go to chemical properties. So metals react with air or oxygen to form metal oxide. Okay, that's the first chemical property that we are seeing. So metal plus oxygen will get metal oxide. Here you can see copper reacts with oxygen, we'll get copper oxide. That is a metal oxide. Then aluminum reacts with oxygen forming aluminum oxide. Al2O3 is aluminum oxide. So metals react with air or oxygen, we'll get metal oxide. The next. Then oxides of metals can react with both acids and bases. Okay. So we'll tell this property as amphoteric property. This metal oxides can react both with acids and bases. So we'll call these oxides, metal oxides, as amphoteric. For example, aluminum oxide can react with acid HCl as well as base NaOH. Okay. When aluminum oxide react with HCl, we'll get aluminum chloride, AlCl3 will get. And when aluminum oxide react with NaOH, we will get sodium aluminate. So that is the second property that we discussed. Then next, metals react with water form metal oxide. Okay, so when metals react with oxygen, we'll get metal oxide. In addition, if metal reacts with water, we will get metal oxide. So that time a specialty is there. This metal oxide again can turn or react with water to form metal hydroxide. Okay, so we'll get it out here when we are seeing this example of sodium. Okay, so what happens here is sodium react with water will get directly hydroxide because sodium is highly reactive. Sodium is highly reactive. Highly reactive in nature. Highly reactive. Same way, aluminum reacts with water, we will get aluminum oxide. So, and we'll get hydrogen as the byproduct. So, we'll consider the reaction of magnesium. Okay. So, magnesium reacts with water. First, we'll get magnesium oxide. That we told that this metal oxide. Magnesium is a metal oxide. We'll get magnesium oxide. Then again, magnesium oxide react with water forming magnesium hydroxide. So this is a typical example for this property. In addition, we are having examples of sodium and aluminum as well. So next, metals react with dilute acids to form salt and hydrogen. So this property already we have discussed many times from chapter 1 itself. Metals when react with acids will get metal, salt and hydrogen. Okay, magnesium react with HCl, we will get magnesium chloride and hydrogen. So next. So the next property is based on the reactivity. Metals of high reactivity react with salt of metals with low reactivity gives displacement reactions. We have seen displacement reactions, and now we will understand how displacement reactions occur. So if a compound, metal compound we are getting, and that metal is less having less reactivity than that of the metal that we are taking, then this metal can replace the other metal from the metal compound. So for example, we can take a zinc react with copper sulfate solution. We'll get zinc sulfate and copper. So copper is less reactive than zinc here. That's why zinc can replace copper from its solution. So metal A plus salt solution of metal B, we will get salt solution of A and metal B. So here is the reaction. That's why reactive metals can displace less reactive metals from their compounds in solution or molten form. So when we are seeing that reactivity series, we will understand this better. Okay. So now we'll see the chemical properties of nonmetals. Nonmetals react with oxygen to form non-metal oxide. Similar to metals, here also we'll get oxides. We'll get here non-metal oxide. Non-metal, carbon is a non-metal. It reacts with oxygen. We'll get carbon dioxide. So non-metals then it do not react with water and acids to evolve hydrogen gas. Non-metals, they are not reactive enough to react with water and acids. Then again, non-metals can react with the salt solution. The more reactive element will displace the less reactive non-metal. Here, non-metal we can take chlorine. Chlorine is a non-metal. It reacts with salt solution. NaBr is a salt. In first class, we told that. So how salts are forming? Acid and base react together to give salt, right? So here NaBr is the salt. Bromide is an ion that can form salt. So NaBr, it is a salt which reacts with chlorine, gives sodium chloride and bromine. So then nonmetals can also react with hydrogen to form hydrides. Here sulfur is a non-metal. It reacts with hydrogen. We'll get hydrogen sulfide. Okay. Do you have any doubts over here? These are reactions, chemical reactions of acids and bases. Do you have any doubts over here? Any reactions? Anything? Hello? Okay. Okay, then now let's proceed. So we'll see now reactivity series. The series in which metals are arranged in the decreasing order of reactivity is known as the reactivity series. And so we have studied in school, right? What is the reactivity series? In the series, what we will do, we will arrange metals on the basis of the decreasing order of reactivity. Okay, I'll show you the reactivity series now. You can see here metals are arranged in the order of decreasing reactivity. So by looking this series, we can say that potassium is the highly reactive among these given metals and platinum is the least. So reactivity will decrease while going down. So most reactive metals we can see at the top of the series. So most reactive metals, what they will do, they will react with water. Then they can react with acids as well. And going down, they will be highly unreactive. And we have included here hydrogen. That's for comparison. Okay. In higher classes, we will study based on this reactivity series. We will see electrode potentials. Okay, we will get electrode potential values as well. So that time we will study more. But now, as of now, you keep in mind that metals can be arranged on the basis of order of reactivity, highly reactive metals that we can see in the top of the table, and less reactive metals we can see at the bottom. So we told that chemical property, right? How it will be, I'll explain to you. If we think of, we have one compound of manganese, say manganese sulfate, or else manganese chloride, MnCl2. Suppose we are having this compound. So this potassium or sodium, any element above that, aluminum or magnesium, calcium, any elements above that can displace manganese from manganese chloride. Any of these elements can displace manganese from manganese chloride, like that. If you're taking the example of nickel, any nickel salt, for example, nickel nitrate. This is nickel nitrate. So nickel nitrate, any element that is cobalt, cadmium, iron, chromium, zinc, any element above this nickel can displace nickel from this compound. That is what we told. Okay. Similarly, for every element, that's why we told, no, zinc can displace copper, we told, right? So copper is having that compound, copper sulfate. So the zinc can displace copper from copper sulfate solution. Similarly, chromium also can displace, tin also can displace. So that is the thing we need to keep in mind. So this is what we can understand with reactivity series. Have you understood this? Okay. So now let's proceed. So ionic compounds. How ionic compounds are formed? Ionic compounds are formed by the reaction of metals and non-metals. That is why we are studying these ionic compounds in this chapter. You have to study the properties of ionic compounds as well. So ionic compounds are formed due to the transfer of electrons from one ion to another. Okay. So it is due to the transfer of electrons that we need to keep in mind. NaCl, NaBr, etc. are examples for ionic compounds. Then next is covalent bond. We know that covalent bond is formed by the sharing of electrons. So we can see in methane here, electrons are shared between two atoms. So usually covalent compounds are formed between non-metals. Okay. So this is a mind map for you. You can take a screenshot of this and you can study this. For a quick revision, you can have a look over this. Then we can recollect everything at a glance. Okay. So now we are coming to the metallurgy part. Okay, first we'll see what is minerals. Okay, let me ask, do you have any doubts till now? Is it okay? We have discussed physical properties, chemical properties. Any doubts in this? Okay. So let's proceed. So minerals. So minerals are elements or compounds that occur naturally in earth crust. Okay. So from that minerals we are getting ores. If we can extract pure metals from any minerals, then these are known as mineral ores. So we can tell that all ores are minerals, but all minerals are not ores. This is a famous saying, like we are studying in class, all ores are minerals, but all minerals are not ores. Consider like ores are small category of minerals, like that. Okay. Okay. So here is another mind map for you. Like here you can see how metals are purified. So we told that there are a lot of minerals present in earth crust. Among that, some are ores. So from some minerals, we can extract metals. So such kind of minerals are known as ores. So first what we will do concentration of ore. Concentration means small impurities will be present in ore now. So that what we will do. So that, sorry, okay, we'll start. So we told what is an ore. Ore is a small proportion of mineral. Actually, okay. Okay, then what is concentration of ore? If you are removing impurities from that ore, that process is known as concentration of ore. The process of removing impurities from ore. That is the primary process that we are doing. That is known as the concentration of ore. Then metals we can divide into three types, like metals of high reactivity, medium reactivity, and low reactivity. We'll see now how metals of high reactivity can be purified. Okay. So for metals of high reactivity, what we will do? We'll do electrolysis. We will do electrolysis of molten ore. Actually, we cannot do electrolysis for solids. So that we will convert to molten phase, and then we will conduct electrolysis, and pure metal is obtained from that. Okay. So next is the metals of medium reactivity. So what we will do with metals of medium reactivity? So metals of medium reactivity may be of two types, like carbonate ores will be there and sulfide. So carbonate ore, what we will do? Calcination. Calcination, that process we will do, we will heat in the absence of oxygen. In calcination, we will heat the ore in the absence of oxygen. In roasting, what we will do? We will heat. Here also we are heating the ore. Sulfide ores, what we will do? We will heat the sulfide ores in presence of plenty of oxygen. So like that, if you're doing that process, we'll get oxides of metal. If you're doing carbonate or calcination or sulfide or roasting, we'll get the product oxide of metal. Then what we will do? We will reduce the oxides. We will do reduction. We will remove that oxygen part. That is known as reduction. Then we will get, we will do purification. So this is what we are doing for medium reactivity. So metals, metal carbonates and metal sulfides are of medium reactivity. Then low reactivity. Okay. So metals of low reactivity, that comes, sulfide ores are of that type. Then we will do same roasting for sulfide ores. Then we will get metal. Then we will refine it. So this is the overall process that is happening in metal purification. Okay. Finally, from this ore, we will get purified metals. Okay. So let's see remaining. Let's see all these things in detail. So extraction of metal containing three main phases. First is the enrichment of ore. Then second is the extraction of metals. Then we will refine it. Enrichment process include, we will eliminate all the unwanted things that is present in ore. Okay. Then second, we will extract the metal. Then we will refine it. So gangue is the different types of impurities such as sand, soil, present in ore. So these impurities are collectively known as gangue. So how we will extract metals which are low activity in low reactivity in activity series. Here what we will do. So low reactivity means these metals are unreactive. So first we will treat that ore with oxygen. We will get oxide. From that oxide, if we are again heating, oxygen will get it will undergo reduction, and we will get the metal, pure metal. So that is what happening here. Cinnabar is the metal ore of mercury. So we will react it with oxygen. We'll treat that with oxygen. We will get mercury oxide. Then mercury oxide, if you are again heating, it will reduce to Hg. We'll get pure mercury here. Okay, then next. Extracting metals in the middle of the activity series. These are moderately reactive. They exist as sulfides or carbonates. We already discussed middle reactivity may be of sulfide ores and carbonate ores. These compounds are having middle reactivity. So first we will convert this metal sulfides and metal carbonates to metal oxides. Then it is subjected to heating in presence of air. If it is in presence of air for sulfide, it's known as roasting. We'll do this in the absence of air, that is calcination. Okay, we can remember this calcination word. We will get confused always. What is roasting and the calcination? Okay, we can remember this way. Calcination, we have already studied calcium oxide. Calcium oxide and calcium oxide is it can abstract a lot of heat. So this calcination, we will use calcium oxide. So it is in the absence of air. Similarly, roasting, what we are doing, we'll make different kinds of roast in kitchen, right? So that is in presence of oxygen only. Okay, so that's why we can differentiate this. So roasting, in the presence of air only we are doing in kitchen. So same, it is applied in the case of concentration or this purification of metals also. So that way. Then, so we'll have now these questions already asked in previous year question papers. What is meant by roasting? What is calcination? What type of metal compounds are subjected to roasting? What sort of compounds are subjected to calcination? So these questions have already asked, and just note it down. Okay. So in the case of zinc sulfide, it in presence of oxygen will heat and we'll get zinc oxide. Zinc oxide then undergoes reduction and we'll get pure zinc. Same for calcination also. We are heating in the absence of oxygen and we'll get zinc oxide. This is carbonate ore, okay? Carbonate, this is sulfide. So we'll get zinc oxide and carbon dioxide. So reduction, metal oxides can be reduced to metal using the reducing agents such as carbon. For reduction, we are using carbon or coke. We will tell carbon or coke. Coke is also used for reduction. Coke is the other form of carbon that also we have already studied. So next is extracting metals towards the top. In the top of the activity series, we know that it is too much reactive. So what we cannot use that common methods that we have employed for low reactivity or middle reactivity. So in such cases, we are using electrolysis. Okay. The process that we are using is electrolysis. So sodium, magnesium, and calcium are obtained by electrolysis of their molten chlorides. So here at cathode, reduction will happen. Na plus abstract one electron forming Na. Here reduction is happening. Oxidation state, it is here, it is +1, Na, it is 0. Elemental state, oxidation state is 0, right? So it is reduction. At cathode, reduction occurs, and at anode, oxidation. Cl minus becomes Cl2, minus is changing to 0. That is, at anode, oxidation is taking place. Okay, so this is the process happening in the case of high reactivity elements. Then now we will see what is refining. So refining of impure metal is done by using electrolytic refining. Okay, so in electrolytic refining, what we are doing, I'll explain with this figure so that you will understand it better. Okay, so we'll take one, we can employ this for any high reactive metals. Okay, now we have taken copper as an example. We'll take an impure rod of copper as anode and pure thin rod of copper as cathode. Okay, so what will happen during electrolysis? In anode, oxidation occurs. So like that, copper will come to, this copper will come to the solution as Cu2 plus ion. So what will happen in this cathode? In cathode, reduction will happen, and this copper will get attached to this cathode. Like that, as time passes, what will happen? All that copper will attach to this cathode, and we'll get pure metal. So this is what happened in electrolytic refining. Okay, so this here, all copper will get attached, and as time passes, this size of this impure copper anode will decrease, and the size of pure copper cathode will increase. This is what happened in electrolytic refining. So we are using electrolytic refining for the refining of highly reactive metals. So this is the thing employed here. So this thing only, it's mentioned here. You can read it out. I'll give you 1 minute for reading. If you have any doubts over here, you can ask me also. In case of copper, any other metal we can choose for electrolytic refining. Actually, here we will get a doubt that, okay, we have already reduced with carbon or coke, that time we got that pure metal only. Then why we are doing electrolytic refining? Okay, in electrolytic refining, what will happen? We'll get the extra pure metals. After this reduction also, there will be some particles of carbon or some other impurities will be there. Still, some sort of impurities will be there. Okay, so after this electrolytic refining only, we'll get highly pure, extra pure metals. Okay. Understood? Is it okay? If there are any doubts, means you can ask me. Okay. Shall we proceed further? Have you understood this process of electrolytic refining? Here we will take impure copper as anode and pure copper as cathode. Okay, this will be a thin rod initially, and as the reaction proceeds, this impure copper anode releases copper 2 plus ions into solution, and this copper 2 plus ions get reduced here at the cathode. Okay, I'll tell you that anode and cathode are electrodes. Okay, so this is anode, this is the positive electrode. Cathode, this is the, sorry, this is electrolytic refining, right? So anode is the negative electrode here. Here we need to note the differences of electrochemical cells and electrolytic cells. In this electrolytic cells, anode is negative. Okay. Charge of anode in electrolytic cell, it is negative. Anode is negative, and here cathode is positive. But this is for electrolytic cell. This is an electrolytic cell. We are doing electrolytic refining here. Okay. Electrolytic cell. For electrochemical cells, galvanic cells, electrochemical cells, this is reverse. For electrochemical cells, this is reverse. Anode is positive electrode, and cathode is negative electrode. This we need to keep in mind. That's why we have given this positive pole of battery. This positive pole of battery we have connecting to this anode. Reverse. So electrolytic cells, anode is negative and cathode is positive. And in electrochemical cells, anode is positive and cathode is negative. This we need to keep in mind. Okay. So shall we proceed? So this corrosion we already saw in first chapter, I think. So the surface of the metals get corroded when they are exposed to moist air for a long period of time. This phenomenon is known as corrosion. This we have already discussed. We can prevent corrosion by painting, oiling, greasing, galvanizing, chrome plating, anodizing, making alloys, etc. This all things we have already discussed. And galvanization is a method of protecting steel and iron from rusting with a thin layer of zinc. We will coat zinc layer over steel and iron. Okay. This is what happened in corrosion. Have you understood this fully? Who has asked? Joseph, have you understood this? And to everyone, is it clear now? Yes. Okay. Then let's proceed. So we have discussed corrosion. I hope it's fine. Then alloys. So alloy is a homogeneous mixture of two or more metals. We know it. So we will make, if metals are having, if metals are not capable of giving that properties in full sense, what we will do? We will make alloys. We will make mixture of two or more metals, and we will make the properties more better, so that we can use it for long time. In a long run, we can use it. So alloys we will prepare. It's prepared by first melting the primary metal. So there will be a primary metal, and then we will dissolve the other metals in it in definite proportion. There will be a definite proportion for dissolving as well. Then it is cooled in room temperature. Then we will get alloys. So electrical conductivity and the melting point of alloy is less than that of pure metals. If we are taking pure metal, it will be having high electrical conductivity, and melting point will be also high. For alloy, it will be less. Then, okay, examples of alloys also. The question has been asked many times. That electrolytic refining also, I think I have seen many places that question has asked. So you have to study these things fully, so that you will get full marks in exam. Okay. So now, iron is the most widely used element. This one we know that we are using iron for many purposes. So in pure state, it's not used. We'll add some amount of carbon to it, so that it will become hard and strong. So we'll make alloys of iron and carbon. We have to note here carbon as a non-metal. Okay, this one also we have to note. Iron as a metal, but here we are adding carbon to make the properties bit higher. Then next is stainless steel. When iron is mixed with nickel and chromium, we will get stainless steel. Okay, so stainless steel is an alloy of which are the metals present in stainless steel? Okay, what is the property that that stainless steel is having compared to iron? What extra property like that we will get? We may get questions. Then amalgam. So, if any other metal is having this mercury element, then we will call it as amalgam, sodium amalgam. So it will be like NaHC couple. So if one of the metals present in alloy is mercury, then we will call it as amalgam. Amalgam, it is mercury. So this word is rarely heard, right? So we have to think that our mercury is also liquid metal. So that like that we can relate. So one of the metal is mercury, then the alloy is known as amalgam. Then brass and bronze. So what are the elements present in brass? So it's an alloy of copper and zinc. Brass contain copper and zinc. Bronze, copper and tin. Okay. Sn. Sn is the chemical name for tin. Okay, then solder. Solder also in many question papers this question has been asked. So it's an alloy of tin, lead and tin. Pb is lead, Sn is tin. So it is having low melting point and is used for welding electric wires. So these properties, we cannot do anything. We have to study it. We have to understand these properties and study by heart. So we will see some of the questions. And after that, I will give you some time for asking any doubts from this class or any previous classes. Okay, so we'll see. So metals generally occur in solid state. We know this. Write the symbol of metal that exists in liquid state at room temperature. That is mercury. Symbol is Hg. Okay, good. Good, Anlia. Very good. So mercury exists in liquid state at room temperature. So from amongst the metals, sodium, calcium, aluminum, copper, and magnesium, name the metal which react with water only on boiling. Can you answer? And another which does not react even with steam. It's steam, okay, not steam. Okay, we'll check the answers. Copper, aluminum, and copper. Okay, think of the reactivity series and answer. Answers, please, quickly. So think of the properties. We know that sodium is highly reactive. So it will react with cold water as well. Okay, sodium is highly reactive. It will react with cold water also. Then calcium is also highly reactive. Think of that group 1 and group 2. Group 1, group 2 elements will be highly reactive. Okay, sodium is highly reactive. Calcium is highly reactive. Now, magnesium. So magnesium is also reactive, but it is coming in that if you're considering the reactivity decreases down the group, right? So magnesium is there. Then aluminum is also there. Aluminum, we are using this aluminum for making vessels and all, right? So it is not that much reactive. Copper. Then the next metal is copper. So which is having least reactivity among this is copper, we can tell. So we got that answer for second question. and copper will not react even with steam. So we'll have now doubts with the no doubts at all. Magnesium, right? Magnesium will react with water on boiling water, right? Okay. So that is the answer. We'll see who all are have given correct answers. We'll see. Magnesium, Joseph. Good, Joseph. Copper, good. Then one answer also, Chrislin, good. Then Anlia, good. Very, very good. Okay, you have answered. First, okay, this way we need to think. Okay, when we are getting a question, we have to analyze it. We know that reactivity series in a rough, it should come to our mind. Okay, so we know that group 1 and group 2 elements are fully highly reactive. So how much things we can eliminate? So that way we need to attempt a question. Okay, the same way we can apply for NEET, JEE and all. You will be studying, or you might have done some foundation courses or something. Okay, so this should be the approach we need to have while solving a problem. Same with mathematics and physics also. When we are doing something, what we have given and what we can extract from that we need to understand first, then we need to answer it. Okay. Okay, so now the third question. Element M forms a chloride with formula MCl2, which is solid and higher melting point. To which group of the periodic table does the element M belong to? So here we can see that which group? Cl2, MCl2, na? MCl2. Cl is having valency 1. So 2 Cl atoms are there. Definitely this ion will be M2 plus. If 2 charges are there, means 2 electrons are released. So which group element will be having 2 electrons in its valence shell? Group 2, right? No one answered. So this way, chlorine, it is valency 1. There are 2 chlorine atoms, so it will be -2. This metal will definitely have 2 plus. So 2 electrons in outermost shell means it is group 2 only. So that way we need to think. So metal belongs to group 2. So, okay, do it quickly. Arrange the following metals in the decreasing order of reactivity. We'll see who will do first. Okay, let's see, no? No answers yet. Be quick. Decreasing order of reactivity. Answer scheme. Okay, K, N, A, C, U, A, G. Correct. And Leah, Krishna. Good. Very good. We'll see the answers. Okay. Anyone else is attempting? Yes. Silver is the least reactive. That is why silver ornaments we are making, right? So on long run, silver also get corroded. We told that black coating over silver due to silver sulfide. Then copper. This is the answer. Good. So next question. So which of the following 2 metals will melt at body temperature? You can give directly answer. I have not given choices. You can directly give answers. Which of the metals melt at body temperature? Which of the metals are having low melting point? Gallium, potassium, Any two. Okay, good. We are getting answers. Okay, gallium and cesium also. Sodium also is having low melting point. We already told, we have discussed that one in first. It's asked for two, so that gallium and cesium. Okay, so these are having very low melting point. If you are keeping that one in hand, it will start melting. If we are keeping these elements in our hand, it will start melting. Okay, so that much low melting point. So next question. Okay, explain why calcium metal after reacting with water starts floating on its surface. Write a chemical equation for the reaction. Name one more metal that starts floating after some time when immersed in water. Yes, and you are correct. In the case of hydrogen, bubbles. In the case of calcium, it reacts with the water. Will get hydrogen. So hydrogen over the hydrogen bubbles, calcium will be floating. Same with magnesium also. Very good. Very good. Okay. So this is a reaction. Calcium plus water gives calcium. We'll get calcium hydroxide. In addition, hydrogen is there. Hydrogen over the hydrogen bubbles, we can see calcium. So magnesium also react the same way. Okay. The next question. So you have to give the reasons to the following observations. So shining surfaces of some metals become dull when exposed to air for a long time. Why? Give answers. Let's see who is giving first. Due to oxidation. Good. Krishna, good, very good. Okay. So shining surface of the metals become dull when it is exposed to air because these metals react with oxygen in the air. Okay, forming oxides, metal oxides. So metal oxide coating will be there over the metal so that the shining appearance will get dull. Then zinc fails to evolve hydrogen gas on reacting with dilute nitric acid. Why? Why for zinc it does not evolve hydrogen gas on reacting with dilute nitric acid? Nitric acid can produce hydrogen when reacting with the magnesium and manganese. Zinc. Okay. Good. And yeah, you people are answering very good. Okay, actually, what will happen? Dilute nitric acid is an oxidizing agent. Okay, so what will happen? Actually, this hydrogen will get formed, but it will again used by this nitric acid. So, as a result, finally, there will not be any evolution of hydrogen gas. That's why. Good answering, good going. Okay, next question. Metal sulfide occurs mainly in rocks, but metal halides occur mostly in sea and lake waters. Why? Why metal sulfide occurs in rocks and metal halides in sea and lake? Make it fast. Let's see who will do quickly, who will do fast. No answers yet? Think. Why? Metal sulfides. What is the specialty with metal sulfide? And what is the specialty with chloride? Okay. Good, Krishna. Very good. So metal sulfides, the characteristic is they are insoluble in water. Okay. So they will remain if rain happens or not. It will remain in rocks itself. That's why metal sulfides are occurring in rocks. But in the case of halides are soluble in water. Okay. So during rain and all, from if it is occurring in rocks or soil, it will carry it to seek and leak. Seek and leak. That's why metal chlorides will be uh, seen in water bodies. Okay. So we'll here you have the answer. Okay. The next question. What is concentration of an ore? Why it is necessary to concentrate an ore before processing? Name an ore of mercury and copper. Ore of mercury we have already told. What is concentration we have already discussed. Then why it is necessary? Before removing that minute impurities, first we need to remove that big impurities, right? That's why concentration of an ore is important. Then tell me an ore of copper. Remaining all questions it's already discussed. Okay, copper glance. Then what else? Copper pyrites. Para. I don't know. Am I pronouncing correct or not? Spelling good. Okay. Para, right? Good. Well done. Okay. Copper carbonate. Hey, copper carbonate is not an ore. Copper carbonate, it is a compound, right? So, copper pyrite is an ore. Okay. Then, okay, good, and Leah. Then we will proceed to next question. It's almost time. Okay, write the balanced chemical equations to explain what happens when mercuric oxide is heated. What will happen? Mercuric oxide react with is heated, will get mercury and oxygen. It undergoes reduction. Okay. So next, cuprous oxide and cuprous sulfide are heated. What we will get? We'll get copper and sulfur dioxide. Both are compounds of copper only. Cuprous oxide Cu2O, cuprous sulfide is Cu2S. If we are heating cuprous oxide and cuprous sulfide, will get copper. That is also reduction reaction. Will get sulfur dioxide also. Then aluminum is reacted with manganese dioxide. Manganese dioxide is MnO2. It reacts with the aluminum. We'll get manganese and Al2O3. Okay. Then next, ferric oxide is reduced with aluminum. So aluminum undergoes oxidation and Fe undergoes reduction. We'll get Fe and Al2O3. When zinc carbonate undergoes calcination, we'll get zinc carbonate and when zinc carbonate undergoes calcination, we'll get zinc oxide and carbon dioxide. Okay, these are the questions we have discussed. These in these reactions or any of the questions or any of the things that we have discussed so far, do you have any doubts? Means you can ask now. Okay, I'll give you some time. You can put the doubts in chat. Please be quick. Okay. We will discuss that question one more time. We'll go back. Okay. Okay, this was a question. Metal sulfide occurs mainly in rocks, but metal halides occur mostly in sea and lake waters. That was the question, right? So sulfides, okay, metal sulfides are insoluble in water. Okay, that's why they can occur in rocks. If rain happens or snowfall or with dewdrops, it will not come to soil. So these metal sulfides, they are insoluble in water. So that will remain in rocks. But in the case of metal halides, what will happen? Metal halides are soluble in water. Okay, when rain comes or with dewdrops or snowfall, what will happen? It will get dissolved in water. And when rain is coming, it will ultimately come to water bodies, either to sea or lake. That is what happened. That is what happening in the case of this metal sulfide and metal halides. Is it clear? Okay, Joseph, I didn't understand which element you are you asking about halogens? If it is like that, halogens include fluoride, chlorine, bromine, iodine, forming halides. Okay, halides will be forming like metals. Will be having different kinds of metals like first group, second group, transition elements. These are all metals. This will react with fluorine, chlorine, bromine, iodine, astatic. So these are the halogen elements. So halogens. Halogens, so these metals react with any of these halogens will get halides. Halides are class of compounds formed of these halogens. Okay. This is how halides are forming. Hydrogen also react with halides forming hydrogen halides. HX, we will tell HX. So X may be fluorine. This is fluorine, chlorine, bromine, iodine, astatine. Up to here only we'll consider because this is radioactive. So this is how halides are forming. Have you understood? Is it clear, Joseph? Anything else? From first class or second class or this class, anything is there means you can ask now. Is it clear? Do you have any other doubts over here? If anything is there means type in chat, okay? Be fast. Joseph, have you understood that how halides are forming? So usually when we are discussing about the solubility, sulfides are insoluble in water, but chlorides are soluble in water. Similarly, nitrates, NO3 will be there now. So nitrates will be soluble in water, NO3 minus. Nitrates will be soluble in water. Similarly, chlorides will be soluble in water. So we'll discuss the solubility parameter later. But as of now, metal chlorides and metal halides are soluble, but metal sulfides are insoluble in water. This we need to keep in mind. Okay. Any other doubts? reply quickly, okay? So that okay. Do you have any other doubts, anyone? If not, there means we will wind up. Okay, do well in your exams. Okay, we have to always study for 10%. We should not study for just passing the exam. So that's a tip from my hand. Always we need to focus on the maximum mark, not how much marks my friends got. Nothing like that. You have to always focus on uh, send percentage. Then only we'll get at least that we can at least come near to that. Okay, so always focus on full marks and study for that. If you are fully focused, and definitely you will get it. Okay, so study well. What all things we are studying, what we need to do, we have to think. Okay, so we have to understand that things and study. It will be like then it will not be a burden for you. Okay, what all things we are studying, study with understanding. So once we understood something, then we will not forget it. There will not be a matter of forgotness. Okay, so that way we have to study. Okay. Okay. Then we will wind up the class. Hope you will perform well in exam. First class and second class include the reactivity. Yes, this reactivity, once we studied that, we can relate this with all the equations that we are dealing with. Okay, so like that only displacement reactions. If one element should displace the other element, means it should have higher reactivity than that of the other. No? So that way. So we are in a process of studying, right? So once we learn this, we can apply it to the things that we have already studied, that we have already covered. Okay, so go that way. If we once we understood everything, we can relate it with what all things that we are seeing daily, what all things we have studied, everything we can do it. Okay, so do well in all your exams, and have a good time and have a high success. Thank you so much, everyone. Good night all.